Okay, good. Alright, sekejap saya tunggu recording Okay, sekarang. Okay. Welcome back to class. We are in week 6, are we? We are in week 6, am I right?
Yes, madam.
Okay, week 6, and you know that week 8, week 8 and week 9 is apa? Your test, yeah? Okay, so now we are in week 6. So for today's class, week 6, we're gonna learn about Newton's second law, yeah? Okay, we're going to learn about Newton's second law. So basically, our objective of today's for the class is we want to state the Newton's second law motion. So first we want to identify the Newton's second law motion. Okay, Newton's second law motion. That is what we want to do. We want to define the mass, and then define the mass and weight. Okay, and then we want to again our cost outcome for the end of the day is the same, whereby we want to analyze the acceleration. Kita nak analyze the acceleration. Hold on, analyze acceleration using the equation of motion, yeah. So we want to analyze the acceleration, and then we want to that is our main purpose lah, analyze the acceleration for today lah. Okay, so okay, now the topic Newton's second law is in topic what? Kinetics, am I right? Kinetics, this is our topic, right? Kinetics of particles. So today we are in our new topic, which is kinetics. Previously we learned about kinematics, right? Okay, now do you remember the difference between kinematics and kinetics? Do you remember what is the difference between kinematics and kinetics? Do you remember, guys? Zuhair, Zakwan, what is it? Siapa yang nak jawab tu? Who wants to answer me? Do you remember what is the difference? Anyone?
Kinematics free fall. Good.
No, kinematics, if you remember my notes, it involves the geometric aspect of the motion, which is acceleration, time, velocity, and position, the geometric aspect. If you remember lah. Now, kinetics, they involve the force of the body. Now we have force involved. That is the difference, okay? Understand? Okay, because previously when you learn kinematics, there is no force involved. Remember, there's no F. Now that we are studying kinetics of particle, we are involving force. That's why we're using Newton's second law. Do you know the formula for the Newton's second law?
F equal to ma.
Yes, F is equal to ma. So now, when you get a question, you must be able to identify, oh, this question is kinematics of particles. This question is kinetics. And the difference is when there are forces involved, whereby you have to use Newton's second law, the topic is kinetics. Okay? All right, kinetics. Okay. All right, I think that is clear. So basically, kinetics deals with the, okay, let me write down what kinetics means, so that you can copy and remember. So kinetics deals with the relationship between the change in motion of a body and the forces that cause this change. Okay, all right. So this is the definition of kinetics. I believe your friend has just arrived. Okay. Oops. Okay. So today we're doing kinematics of particle. Okay. So so the basic of kinetics of particle is using F equals to ma, which is this is what you call the Newton's second law lah. Okay. So basically for the topic chapter 2, what we're going to do is we're going to use Newton's second law, F equals to ma throughout our study lah. Okay. All right. Okay. Um. All right. So basically, F is the force whereby we want to examine the force, and A is the acceleration, and M. What is M?
Mass.
Yes, M is the mass. Okay. All right. Okay. So everybody understand that, yeah? Okay. So everybody understand this is what we're gonna do today, yeah? Okay. Now. Okay. Remember last time there are three types of coordinate system that I taught you? Remember? Do you remember?
Yeah.
What is it?
Um,
The rectangular,
curve linear.
the one using the rectangular coordinate system. Remember that?
Yes.
And the other one is the non-rectangular.
Non-rectangular.
Non-rectangular ada dua, which is
Normal and tangent.
normal and
Yeah.
tangential. And the other
Radial.
one is radial
Radial.
and
Tangential.
no, transverse.
Transverse. Sorry.
Okay, now for topic Newton's second law, we are going to repeat the same thing. Okay. So now you understand. So now for topic Newton's second law, we are going to use F equals to ma for rectangular coordinate system. And then we're going to use for, F equals to ma for the non-rectangular system, for normal and tangential, and for radial and transverse. So we're going to repeat the same thing. But this time, the difference is we're going to use only F equals to ma. We're going to use Newton's second law. Okay, do you now understand? So when you get a topic on kinetics of particles, which we are going to use Newton's second law, you are going to look at the question. Oh, this question is normal and tangential. This question is rectangular coordinate system. Or this question is radial and transverse. But using what? Newton second law. Okay. So there are three types that you have to identify. So it's the same thing that we did last time, but now we're going to focus on kinetics of particles. Okay. So as long as you get the idea, for topic kinetics of particles, we have Newton's second law, F equals to ma. And again, I have to decide which is the best coordinate system to use to solve the problem. Okay. Now, do you understand the overall picture for topic 2? Do you get it now?
Yes.
Yes,
Okay,
madam.
good. Okay, once you get this, you understand this, then you're not going to be confused when you get the question. Okay, all right, because we have already gone through a lengthy discussion on these three types of coordinate system. Now the difference is we're going to use Newton's second law for it. Okay, that is the difference, yeah. Okay, all right. So now for the rectangular coordinate, for the okay, for the rectangular coordinate system, hold on. Okay, but before, okay, hold on. Okay, now I'm gonna go here. Okay, now. So basically, our objective again, I'm gonna remind you what we want to do. We want to solve dynamic problem using Newton's second law. Okay, all right. Now, okay, let's say you have a particle. Let me draw this particle. We're still in topic particle, and you have a lot of forces acting on it. Okay. because now we're involving forces, right? So there can be more than one forces involved. Okay. There are a lot of forces involved onto it. Okay, now, so when you want to, what you need to do, you need all these forces, you have to make it become one force. So when you become one force, what will become? It will be a resultant force F. Okay, all right. Okay, and this resultant force F is your free body diagram. Okay, and it must plus with another diagram. This other diagram is what you call the kinetic diagram, KD, kinetic diagram. D, D, D. Okay, and your kinetic diagram is M equals M multiplied by A. Okay, so whenever you get a question on topic kinetics of particle that uses Newton's second law, there are two important things that you need to draw. It's very important that you draw the free body diagram, and it's very important you draw the kinetic diagram. So these are the two things that you need to draw. Okay, and then when you draw these two things, you also have to decide which coordinate apa system you want to use. So these are the three coordinate system. Coordinate system. Oh, tebalnya. Hold on. Coordinate system. Okay. So there are three. It means when there are three types of coordinate system, it means there are three types of examples that we need to understand and do in order to understand how to use this. Okay. So there are three important examples. So we're going to do one example on the rectangular, another example on the normal and tangential, and another example on radial and transverse using F equals to MA. And once you understand these three examples, then if you get any question, you can solve it. Okay. All right. Okay. Okay. All right. Now, okay. Okay. Now, let's go straight to the example to understand. So example one, what we're going to do is we're going to use the rectangular coordinate system for example one. So can you please copy this question? I'm doing a simple question so that you apa do a simple question first. The 50 kg crate. Are you copying, guys?
Yeah.
Yes, madam.
Okay. Okay, now, okay. The 50 kilogram crate shown rests on a horizontal surface for which the coefficient of kinetic friction is mu k 0.3. If the crate is subjected to a 400 Newton force, determine the velocity of the crate in 3 seconds starting from rest. So for this question, they ask us to calculate the velocity. Okay, how are you going to get the velocity? Okay, how are you going to get the velocity? Now, for this question, understand that we are in topic kinetics. How do you know that we are in topic kinetics? Because there is a
Of
how do you,
course.
Force.
there is a force. Okay. That is good. Okay, but they ask us to find the velocity. So, as you know, this topic kinetics, they give you the force, so you know you have to use F equals to ma to find it. But right now, the question is they ask you to find the velocity. So, even though you have to use the basic kinematic equation also. Now, for the basic kinematic equation, which formula do you think you need to use to solve the problem? Now, remember the basic kinematic equation? Remember there are two types. One is the basic kinematic, and the other one is the one with the constant acceleration. Remember that?
Yes, madam.
Okay, now, to find the velocity, which one you want to use?
Constant acceleration.
Okay, why?
Yeah. Because F equal to
Sebab dia punya velocity.
Hmm?
Sebab dia punya velocity bertambah.
No, because the acceleration, this acceleration is constant. Because the acceleration is constant, you are going to use the constant acceleration formula. Now, remember there are three types of constant acceleration formula. Remember?
yes, madam.
What is it? V equals to V naught plus ACT lagi.
S equal to S naught
S.
S naught plus
V naught T plus half
V naught T
AC
plus,
V squared.
and then one more.
One more is V squared equal to V naught squared plus 2AC S minus S naught. T naught.
Okay. Now, so when you get this question, the reason why you need to use the constant acceleration formula is because F equals to ma, A is constant. Okay, when A is constant, that's why you need to use this formula. So when you read this question, they ask you to find the velocity, you need to rely on this formula. Now, when you look at this formula, which formula that you can use to find the velocity?
Satu yang
Okay,
first.
satu first. Okay. So now we have identified we need to find V equals to V naught plus ACT. Okay. That is good. Okay. Now, do you have this is what you want to find. So what you want to find is this velocity. Now, do you have V naught?
Yes.
What is it?
0.
Zero. Why zero? Where does it say?
At
Because
rest. At
starting
rest.
at rest. So this one, because it says it's starting at rest, so V naught equals to zero. Now, so basically what we need to find is we need to find AC. And do we have T?
Yes.
What do we have? T is
3,600
okay.
seconds.
Now, this technique that I am teaching you is using the what do you call the technique that I named this is the backway technique, whereby we look first what the question asks you to find. Oh, it asks you to find the velocity. So now, so once you know they ask you to find the velocity, you go and find the formula. Okay. After you have found the formula, you look at the variables that is given to you and what variables you need to find. Okay. So that's why in class, discussing a question together is very important, because if you look at the solution in the textbook, or it doesn't start with v equals to v naught plus act. It starts with F equals to MA, then you will get confused. Okay, so I like to use the backward technique because it guides you on what you need to find. Because most of the solution in the textbook or in any book, what they do is they give you they ask you to find AC first. So when they've asked you to find AC, later on only they give the formula for V. So for me, that technique is very confusing. We have to start from where they ask the question first. So when they ask the question, the velocity, what we do is we work our way backwards to see what we need to find. Okay, that is one technique that you need to understand in helping you to do better in subject dynamics lah. Because if you rely too much on the solution in the textbook, they don't guide you that way. They don't go backwards. Okay, maybe you don't understand now, but sooner or later when you see that how I try to solve the problem is a bit different the way on how the textbook explains. So, but to me this technique is better for you. Okay, now, okay, since we know we have to find AC and T, and we know that we have a force, so we need to use the Newton's second law formula. Okay, now the other important thing for this question is the free body diagram. Okay, now, so first we need to draw the free body diagram. Okay, okay, the free body diagram students always miss, and it costs a lot of marks. Okay, I repeat, okay, make sure you draw the complete free body diagram. Okay, for a free body diagram like this, of course, you have a force, and the force is given to you, which is 400. Okay, now for this question, we're going to use the rectangular coordinate system. That's why we're going to resolve all the forces. We need to resolve the forces in what direction?
X and Y.
X, Y.
Yes. So all the forces that you have in this diagram, in this question, you need to resolve all of it in the x and y direction. Okay. Okay. Now, okay. So now, for usually for a diagram like this, discrete, you will have a weight. The weight will be drawn at the center. Okay. Some student they draw atas ni lah, bawah ni lah. Okay. Please don't do that. The weight should be at the center and it should be vertically downwards. Now, weight is equals to what?
MG.
G.
Mg. Okay. When you have a particle that is on this platform, okay, it has to be in equilibrium. If it has a weight, it also will have what?
Normal.
Normal force.
It will also have a normal force. Okay. All right. So, and then the other thing, you have to check, is the surface smooth, or does it have
Friction force.
friction? So it has a friction, doesn't it? So what is the friction force? The friction,
3.
mu k is 0.0.3.
0.3.
So the friction for this is usually mu k n. Okay, the friction is mu k n. Okay, so 0.3 multiplied by n. Okay, so this is the complete diagram for the free body diagram. You will get full marks if you do this, but you must not forget, it must equal to what?
Kinetic diagram.
Yes, kinetic diagram. So you must draw the kinetic diagram also. Now, how do you draw the kinetic diagram? Okay, now, okay, the technique is, okay, now I'm going to talk to you about the procedure for the analysis, using the rectangular coordinate system. So for the procedure, number one, you have to select a type of coordinate system. Okay, so the type of coordinate system that you have select is the rectangular coordinate system. So this is where you identify the x and y coordinate, right? And you have resolved everything in the x and y coordinate. Okay. Once you have established the coordinate system, it's very important to draw the graphical presentation whereby you all draw the forces acting on the particle, okay, in the x and y components. So that one you have done. Okay, now the next is, and the kinetic diagram. Okay, the next is for the kinetic diagram, you have to have a sense of particle acceleration. Now, how do you think the particle, the acceleration of the particle moving to the right? You can assume it. Okay, all right. Now for this question, did they give you a direction of where the particle is moving for this question?
No.
No. So
No.
what you can do is, we can assume that it is moving in the, you can establish the direction. So let's establish that the direction is moving to the right like this. Okay, all right. So, apa? The reason why I established the direction is moving to the right is because I want to have a positive inertial coordinate exists, because I have assumed the positive to be ni, the x ni. As you can see, my x is positive moving that way, and my y is positive you going upwards. So because I want a positive direction, that's why I assume my acceleration moving to the right. Okay, this is very important, yeah, because this question is straightforward. Okay, it's a simple crate box. If you notice in the tutorials or in the example that we did in class, and also, no, we did not do in class, an example, I gave you a video to watch, right? Okay. And also other examples, you will notice that the crate can be in many position, like in a slanting mode, like this. The crate can move like this. The crate can move downwards, or the crate can be hanging like this. Okay, there are a lot of examples. So these examples, you have to be able to identify the movement of the acceleration. Understand, guys?
Yes,
Okay.
madam.
All right. So my way is, usually I will assume the direction to be in the direction of where I assume my x and y to be positive. But it's okay. Let's say you get your answer to be your acceleration to be negative. What does it mean? It means the assumption that
Means
you assume is the other direction. Itu saja. Okay, all right. So that's why we need to assume. Okay, so to make it safe, we always assume it to be in the positive coordinate axis lah. Okay, so our direction of MA will be like this. MA. Okay, boleh tak? That's why I start with a very simple example. So as long, and later on when you start doing a lot of tutorial, example or final exam questions, you will get used to it. Okay. Right. Okay. Am I okay? Can we now continue?
madam, kalau free body diagram tu kalau buat satu point je tak payah lukis gambar tu boleh ke? Maksudnya pakai paksi.
No, no, no. You have to draw the diagram, because the weight, because your free body diagram can look like this, can look like this, you know. So we don't know where you're assuming your dot is. You want to just draw the dot like that. Is that what you're trying to say?
Yes, madam.
Oh, no, no. Can you please draw the complete diagram so that it doesn't make mistake?
Okay, madam.
Okay. All right. Okay. Now, so now we want to do is we want to use the equation to use in the free body diagram. Okay. So now we have assumed, what you have assumed is your acceleration like that, right? In that direction. Okay. Now, so we're going to use the Newton's second law. So we have, since the Newton's second law for this question is using the rectangular coordinate system, we have x equals to ma, and we also have fy equals to ma. So fx is in this direction, positive and Fy is positive in this direction. Okay, now. So what is, okay, have a look at this diagram, this free body diagram. What is, do you have Fx?
Yes.
What is it?
Sine cos 400.
Okay.
Okay.
Now your Fx is in a slanting at 30 degrees, right? It's not in the X and Y coordinates. So what you need to do is you need to resolve this. Am I right?
Yes, madam.
So if you resolve this in X and Y direction, if you resolve it in X, what it will be? 400 sine or 400 cos?
Cos.
Cos 30. Okay. This one is 400 sine 30. Okay. All right. Now only you can begin because everything is in the X and Y coordinate. So let's have a look what is in the X coordinate. We have 400 cos 30. Okay. Do you have anything else in the X coordinate?
Friction.
Yes. Okay. Now, right. This is another thing student always makes mistake. Okay. Since the acceleration is moving to the right, the friction should be in what direction? The same direction or the opposite direction?
Opposite.
Left.
Opposite. Okay. So you need to draw friction. Okay. Because we don't want to confuse F with force and friction. So what we do is F, capital F and small f, friction force. So friction force is equals to mu k n. Okay, this one lah, sama lah. Okay, this is friction force. Okay, so we have another one which is this one. Do you have anything else in the direction of X? Is there any diagram you see here in the X direction? There is one more. Hello?
MA.
Yes, MA. Don't forget MA. Okay. All right. So when you write it down, so let's do this one first. 400 cos 30 because this is positive. Okay. And our mu k is negative, right? 0.3 n. Okay. Equals to MA should be positive or negative?
Positive.
Yes,
On.
MA. This is mu k n. Okay. All right. Okay. There you got your first equation. Okay. Now for the second equation, let's find the equation in the y direction. So in the y direction, what do you have? You have the normal and you have
Weight.
what? And you have the weight. One more. What else?
Force.
Yes, this
Ah,
one. Okay. All right. Okay. I'll tell you, usually students love to do questions related to Newton's second law because it's interesting for them. But however, sometimes students make careless mistakes where they miss out some of the forces. Okay, please don't do that. This is the simplest question. Okay, when you will see that the question gets harder and harder, there will be a lot of number of forces involved. So don't miss out. Okay. All right. So for the Fy direction, we have N, normal force. What else you have? You have the weight. Okay. The weight is mg. Now, the weight is negative, right? Do you agree that the weight is negative?
yes, yes.
Okay. Because it's the direction, because we have assumed positive going upwards, and then we have plus 400 sine 30 equals to what? Equals to?
Zero.
Equals to 0. Why? Because there is no, in your kinetic diagram, you do not have MA in the vertical direction. So this is 0. Okay? Maybe in the future questions, something like this, something that is like this, you might get this kind of questions. For this question, yes, you will have MA. You will have MA in the vertical direction. But for now, for this question, we do not have. Understand? Okay, for future questions,
Yeah.
okay. All right. Okay. So students selalu always, make mistake and put MA in the FY direction. Okay. All right. Please don't do that. Okay. Now. Okay. If you okay. Now. Let's simplify this question. Actually, you can find you do you have M?
Yes.
You have M. So let's write M because we forgot to write M. M is what? 50.
50.
Okay. And then 50 times 9.81. Okay. Now, so if you notice at this question, what can you do? You have two equations, and how many unknowns you have? You have two.
2.
So it means you can find me what is N and what is A. Can you please calculate for me, find what is N and what is A? Yes?
And 2905. 8.5.
What is N?
What is N? 290.5 Newton.
Correct. What is A?
5.19.
Unit. Units.
Meter per second square.
Okay, now. So now you have got your A. Then what you can do is you can find your velocity.
Velocity.
What is the answer?
.57 meter per second.
Okay, that is correct. Okay, now let's recap back. Okay, all right. Now, okay, for this question, okay, they ask you to find the velocity, and because the crate is subjected to a 400 Newton force for 3 seconds, it means the acceleration is constant. That's why we use the first formula, V equals to V naught plus ACT. However, there are other questions that is not necessary using the constant acceleration. You have to read the question carefully. Okay, it depends on the question. There are certain questions where you do not use the constant acceleration to solve the problem. It could be using the basic kinematic equation. Okay, right. Just be alert. Yeah, that's why we need to read the question carefully and identify which is the formula you want to use. Okay, so for this question, this is using the basic. The rectangular coordinate system. That's why for this question, all the forces you need to resolve in the x and y coordinate, but to find the acceleration, we need to use the Newton's second law. That's why I said in the earlier part, our main purpose was what? Using the Newton's second law, whereby we want to analyze what? The acceleration. So that's why the Newton's second law, F equals to ma, is used to find what? Is used to find the acceleration. Okay, all right. Now, okay, so this is very easy. I have a question for you to try, which you can try and then you can check the answer with me. Okay, many of you have also given me some of your work that you have done and asked me to check. Mostly, I can say that I have replied most of them. And then some of you have written back to me and informed their updates. I will reply back soon for those who have contacted me personally. Okay, so thank you for those that have done their homework and have asked them to check. Ask me to check. However, I need to reply some of your messages back. For those that I haven't replied, I will try to reply within this week. Okay, so now I would like you to try this question. However, I will not discuss in class. I want you to try and then come back to me with the answer lah. Okay, can you do that?
Yeah.
Yes, madam.
Yes, the
Okay. You have class after this?
Yes.
Okay, kejap je.
Yes, madam.
Just give me a second to complete this.
Okay, madam.
Okay, all right. So this is the question I asked you to do. Okay. Okay, so you can do this question and then you can come back with me and discuss the answers. Okay, so I will stop recording now. Okay.